You're here for the prompt to production, building automated controls using generative AI. And what if you can define a control in a natural language and you can automate it? Just by a show of hands, how many of you work in GRC or IRA space? Oh, nice. How many of you work with security teams, either in security or work with security teams? A few. Um, and so what we want to basically show you today is that how do we use large language models to be able to take controls and automate them and to execute them deterministically across your entire enterprise at cloud scale, right? Now, how many of you have heard of this Anthropic Glasswing that came out? Okay, Mark. Okay, let me give you a quick recap. April 7th, Anthropic released in preview a model called Mythos. And the project was Glasswing, which is a collaboration with a bunch of different companies, where they autonomously found vulnerabilities in kernel code base, a lot of other things in addition to kernel code base. And these have been vulnerabilities that are zero-day vulnerabilities that have been resident for 27 years. So the maturity of the models and where we are has gone much further than where we have ever seen. And we are in a seminal moment. I think if many of us would have already known this, because a few weeks even before the project got announced, there was a presentation by a security researcher at Anthropic, Nicholas Cardini. I don't know if you want, you should definitely go. You can scan it; it'll take you to the YouTube video. You should definitely listen to it, where he went and used the existing models to automatically detect vulnerabilities. Now, why is that relevant in a GRC conversation? Because what we want to do today is that this is not a commercial pitch. But both of us work for a company called Compliance Cow. But what we want to do today is to take a general approach in terms of how, as a practitioner, we would automate. Because the impact of these vulnerability tools, the maturity of these models, have a significant impact on the GRC teams as well. The question is, what would the GRC teams do when you're faced with these watershed moments? And what we want to do is that rather than talk about access control or one of these common controls, we want to take a simplistic example of taking a zero-day vulnerability and writing an automated control around that vulnerability to see if we can execute at scale. So far, so good. All of you guys with me? Okay. So I don't know if we'll have the time to do this. This is a 15-minute talk to walk through both presentations, but we are going to do maybe the first one, but we are here to always answer other questions. The one question I want to tell you is that, are you familiar with this? Have you seen the movie Ratatouille? Right? Chef Gustav says anybody can cook. And that's the way I look at large language models. Anybody can write, but even the greatest chefs needs the great tools and great ingredients. And that's what all of us provide, right? And you need the right tools and you're in the right place to be able to use those large language models to make it work for you. So, and that's what we wanted to do today, rather than walk you through the slides, show you how we can enable some of that happen. But some of this we open sourced a single threaded version of what Megha is going to walk you through. She's going to walk on the commercial platform. But if you scan this, you'll go to opensecuritycompliance.org. You'll hit a GitHub repo. You can Docker compose up. You can go try this out on your own as well, right? And you can bring your own large language models. So what I want to basically, before I hand it over to Megha, I want to maybe paint the picture, right? Continuous controls monitoring, as you may all know, is all about connecting with systems, collecting data, and making it very meaningful from a risk compliance and an audit perspective. And we have seen that evolve. I think the first version of it was to take the existing process and automate screenshotting. The RPS were extremely helpful to do that, and that is fantastic. But that wouldn't suffice, because you're dealing with a new problem with a old set of recipes, right? And the APIs have become very, very mature in the last few years. APIs have become sort of very central to a lot of things that we do. And we have actually automated a lot of things using the APIs as well. But the challenge is that APIs are rules-based. And in order to automate, you'll have to write these rules. And there lies it's a challenge. The time it takes for you to write the rules, the skills that you need to be a developer, a Python developer or a Go developer or a Rust developer, to be able to write these transports and to be able to collect the data, the time it takes for you to deploy was all taking a lot of time. Now we are in the agentic world, and that story has completely changed, right? Because now what has happened is that the idea of how you consume data has fundamentally changed. I don't know how many times I've gone into the UI last time. I don't use the dashboards anymore. I just converse. And that's exactly the same thing that we are seeing with our GRC communities as well. And the tools will also all to change. So we actually have come up with this nomenclature called CCM 3.0, where it is beyond the way that you think about APIs and how do you use agents to automate these controls. So, and I wanted to sort of explain this, and Mega will walk you through a very specific example of this, is that the way we see this is in 4 steps. One, how do you describe a control state? And in this example, we are going to use a CVE, capture the content of the CVE to try and automate. But the idea is to how do you engage as a user? How do you provide context to what you want to automate for controls perspective? And the second thing is that use generative AI to be able to design this. Why do we want generative AI are fantastic design tools, but they are extremely bad runtime tools. And let me explain. Because generative AI are fundamentally probabilistic, and we in GRC and security are used to dealing with deterministic outcomes. So the question is, how do you bring these two worlds together? And that's what we want to sort of show you, where you want to be able to use generative AI to design into deterministic sort of steps. And how can you use tools to do that? The third thing is, once they have designed them, how do you deploy them? How do you deploy them at scale? It's one thing to execute a bash script. It is an entirely different thing to execute this across your entire enterprise. It is one thing to write a Docker file. It is an entirely different thing to be able to manage and orchestrate across all your Kubernetes clusters. And you need to be able to do those things as well. The last thing I would say is that, so you need to be able to simulate, run, and test, and you should be able to deploy this. So what I'm going to do is that I'm going to hand this over to Mega, where we hopefully can show you how you can go from a design, wipe code a design, create a deterministic sort of set of structures, execute them at scale, and deploy them at scale as well. Everybody good? Okay, I'm handling.
Okay. Thank you, Raj. Are you able to hear me? Yeah, okay. So Raj was talking about a chef. That's me. So now that we have all the right ingredients and the great tools, let's start building the dish. Okay. So what we'll start, we'll take an example where we'll list down all the CVEs. Okay. And then we'll pick one of the CVEs and we'll use our agentic AI to create an automation that will assess that vulnerability across our Kubernetes clusters. Okay. So the first step is I will start with listing the CVEs in the system. Right. As you can see, it listed all the CVEs. Let's zoom into the first one a little. So this one is Ingress. This is related to the Ingress NGI and its validation admission controller. Now, what it means is any attacker can get into your Kubernetes cluster. It can run malicious code by gaining unauthorized access, okay, which is dangerous, right? Now, it is only in specific versions of NGINX. So if you're in v1.11.4 or v1.12.0, then you are vulnerable. And then the remediation is either you upgrade your version or you disable the validation itself, right? So with that, let's start building the agent. So now I interact with the agent by giving this prompt. Let's create a rule to assess the CVE or my Kubernetes clusters, right? So now the AI agent will give me with a game plan. Okay, it came up with these 6 tasks. Now these 6 steps are sequenced by the AI, and all we need to do is review them. Now at this point, I can also prompt it and make changes. Okay, now once I'm good with this task, let's review them. The first and the second task, they are basically fetching the resources from the Kubernetes cluster. The third and the fourth, they're going to flatten the data. And the fifth one is going to do a join on both of the inputs. And the sixth one is the final one where we evaluate that, okay, whether all the resources that we have got from a Kubernetes cluster, whether they are vulnerable for CVE, for the given CVE, right? But what happens in the backend is the AI Studio will create the system workflow. So it pipelines it auto wires all of these tasks and it creates the system workflow. Okay, as you can see, and in the back end, there's a Python or Go code that is auto-generated. Okay, now these are the steps. We have different inputs. We also have the outputs. Okay, you have the CV compliance report, you have the CV status, compliance status, and the compliance percentage. Okay, so we started prompting from listing the CVE and we designed a rule. Okay, what next? We need to unit test it. So you can give your credential here or you can pick the application integration from the platform. Okay, now let's start executing the rule. Okay, so we'll ask the agent to unit test the rule. We'll execute it. So it connects to the available Kubernetes clusters that are reachable. And you can even monitor the progress of execution here. In case there are any issues, it will let you know what is the log file. You can troubleshoot. You can even prompt it to troubleshoot and fix the issues, right? Now, as you can see, here for a given cluster, it identified that for these namespace, like say, let's zoom into the first one. This is non-compliant. Why is this non-compliant? Because as you can see, the webhook is active and the version is also not up to mark. So this is non-compliant. Now here we have a proper version and it's active as well, right? So let's zoom into the third one. Now here it's inactive and then it's inactive. So of course we have reduced the attack surface, but there is a flag, right? There's a flag because the version is not up to mark. So you still need to patch the vulnerability. And yeah, same goes with the next. So we have executed, unit tested our goal. It's now ready. Now wipe coding is great, right? It's great. One script, one cluster, few clusters, maybe 10 clusters. Very good. Now what if you have thousands of clusters running in production? You multiply them by the number of namespaces, multiply them by the number of deployments. Your infrastructure is going to fight back. You'll run into all the hallucination, you'll run into throttling issues, rate limit issues. So that's where the orchestrator steps in, the compliance cow orchestrator. So the compliance cow orchestrator. So next step here is to publish the rule, deploy it, attach it to a control objective, and then you can have a set of applications. You can create an application scope, have all your Kubernetes clusters configured as part of your application, execute at scale on thousands and thousands of Kubernetes clusters, and you will get deterministic output every single time. So we cook the dish and at scale. And with that, I'll hand over to Raj.
So I just want to make it very clear. We wanted to stay away from a commercial conversation on compliance cow. That was not our idea. A lot of this in the commercial, we as a platform we provide. But I want to impress upon you is that when she showed you how to wipe code, if you go try to do that with your Claude or OpenAI, you will find completely different results. That's because you don't have the same tools. It'll give you a bash script at best that you won't be able to execute. What Compliance Cow basically does, and you can actually, we have open source this as well. By the way, you don't have to buy a commercial product. Go try this out. As I told you, there is the open source version. You can click and you can download and you can bring that up. What it gives your Cloud Studio or particularly ServiceNow Assist, because we have integrated with Assist, are the tools where you can start building these deterministic system workflows that Megha talked about. That's what we do. Once you do them, you can deploy, right click, and into Compliance Cow. And you actually won't even know that Compliance Cow exists because all the data will get collected, normalized, standardized, aggregated, and pushed into ServiceNow IRM for continuous controls monitoring. So the key takeaways is, how do you do this without sacrificing speed? How do you create deterministic outputs? How do you create them, accelerate them as in a way that you're very comfortable with, right? And I think again, I go back to Chef Gustav, anybody can cook. Thank you.